Good day, ladies and gentlemen. This is Dr. Ferrer, your professor and research in social studies. Our topic this morning is on choosing the right statistical tools. But first, my question is why we need a statistic in research. Research aims to discover phenomena that we assume actually exist. Whatever the phenomenon we desire to explain, we collect data from the real world to test our hypothesis about the phenomenon. Hypothesis testing must involve statistical technique. There are two statistical techniques, the descriptive statistics and the inferential statistics. Descriptive statistics pertains to collecting, organizing, summarizing, and presenting data, while inferential statistics is more on making inferences, hypothesis testing, determining relationships, and making predictions. In short, descriptive statistics uses statistics that describe numerical data, frequency distribution, central tendency, variation, and data shape. Descriptive statistics are statistics that describe numerical data through the use of frequency distribution, central tendency, variation, and data shape. Now let's discuss it one at a time. We have to first discuss frequency distribution. Frequency distribution is the easiest way to describe numerical data, and usually this can be presented in tables or a graph. As you can see on the slides, you have there an example of frequency distribution being presented in a table as well as in a graph. Now we have the second descriptive statistic, which is central tendency. There are three measures of central tendency. You have the mode, the median, and the mean. When we say the mode, that is the most common or the frequently occurring number in your data. This can be used with nominal, ordinal, interval, and ratio. The second is your median. This is, of course, the medial point of your data, also known as the 50th percentile or the second mean or the second quartile. This can be ordinal, interval, and ratio. And of course, the third is the mean or the arithmetic average. This is most widely used measure of central tendency, which can be used with interval and ratio. Then the third is the variation. This is measuring how data spread and vary. We have the measure of the range, which is the subtraction between the maximum value with the minimum value. And this is, of course, the easiest way to measure variability. This is very sensitive with outliers, or those that are away or detached from your data. Then another is the percentile. This is where data were being divided into 10 parts. Percentile tell us the score at a specific position within distribution. This is the calculation of percentile is similar with your median. Then next is the variation. Of course, one of which is the standard deviation. This gives the average distance between all data and the mean. Standard deviation is the most comprehensive and widely used measure. This can be used only with interval or ratio data, and it tells us the score of a specific position within distribution. The standard deviation measures the amount of variation or the dispersion of a set of values. A low standard deviation indicates that the values tend to be close to the mean of the set, and the high standard deviation indicates that the value are spread out over a wider range. Then for the measures of shape, you have one skewness. This is said to be an important measure of the shape of a distribution. Skewness is the distortion or asymmetry in a symmetrical bell curve or the normal distribution in a set of data. If the curve shifted to the right or to the left, it is said to be skewed. Skewness can be quantified as a representation of the extent to which a given distribution varies from normal. So the Pearson coefficient of skewness. The formula in measuring the Pearson coefficient of skewness is skewness is equals 3 times mean minus median over or divided by standard deviation. Skewness can be symmetric, positive skewed, or negative skewed. We have symmetric skewness if the mean and median are equal and the data values are evenly spread around these values. Value of Pearson skewness is 0 and value in software skewness is near 0. This is symmetric skewness is true if it looks the same to the left and right of the center point. Looking at the illustration in your slide, you have there symmetric skewness is where the mean and the modes are the same on the left or right of the center point, which is the median. Second is the positive or right skewed, where the mean will usually be more than the median value of Pearson skewness, and the value in your software skewness is positive. And the positive skewed, the tail on the right side of the distribution is longer or fatter, meaning the mean and the median will be greater than the mode, as you can see in the example in the slide. While the negative or left skewed, the median will usually be more than the mean. As you can see on the illustration, the tail on the left side of the distribution is longer and fatter than that of the right side. Then we have the Cortices. This measure provides information about the wickedness of the distribution. Cortices is actually a statistical measure used to describe the degree to which scores cluster in the tails or peak of a frequency distribution. The peak, as you can see in the illustration, is the tallest part of the distribution, and the tails are the ends of the distribution. If you have 0 or near 0 Cortices values, that indicate that the distribution is normal, and sometimes it is called mesocortic. Mesocortic is used to describe the outlier's character of a probability distribution in which extreme events or data that are rare is close to 0. On the other hand, positive Cortices values indicate that the distribution is rather peaked because many cases clustered in the center. This is sometimes called leptocortic. So, leptocortic is a statistical distribution with Cortices larger than that of a normal distribution, as you can see in the illustration on the slide. While negative Cortices values indicate that the distribution is a distribution that is relatively flat because too many cases in the extremes. Sometimes it is called platycortic. Platycortic is a statistical distribution in which the existing Cortices value is negative. This will have thinner tails than a normal distribution, resulting in fewer extreme positive or negative events. Warning about the use of Cortices and skewness. When you use large sample, skewness and cortices could be inaccurate. So, inspecting the shape of the distribution using histogram. Now, to assess normality, normality tests are used to determine if a data set is well modeled by a normal distribution. Normality tests help us to determine what statistics technique we should use. So most of inferential techniques require normal distribution. Now let's proceed with inferential statistics. We have test of relationship and test of difference. Under the test of relationship, we have correlation. And here, the Pearson or the Spearman correlation can be used to explore the strength of relationship between two continuous variables. So we use the Pearson for normal distribution and the Spearman for not normal distribution. This test will give us direction and strength of relationship. Any positive correlations, that is if one variable increase while the other would also increase. And a negative correlations, that is if one variable increase, the other would decrease. Another is that of Lind, Markle, and Watson in 2012. The correlation is interpreted as 0 with no correlation, 0.10 to 0.49 as weak correlation, 0.5 as medium correlation, 0.51 to 0.99 as a strong correlation, and 1 as the perfect correlation. Then another is the correlation by Cohen, where 0.10 to 0.29 is said to be a weak correlation, 0.30 to 0.49 as medium correlation, and 0.5 to 1 as a strong correlation. Then another is the partial correlation. This measures the degree of association between two random variables with the effect of a set of controlling random variables removed. This is said to be the extension of correlation that allows us to control another variable. This test allows us to get more accurate picture about a relationship between two variables. Then another test of relationship is the simple or multiple regression. This is a sophisticated extension of correlation. This test is used when we want to predict ability of a set of independent variable or variables on one continuous dependent variable. As I said, simple or multiple regression is being used to predict the value of a variable based on the value of two or more variables. Another test of relationship is logistic regression. This is similar with multiple regression, but use categorical dependent variable. The dependent variable is better to be dichotomous, and it doesn't have the requirements of the independent variables to be normally distributed, linearly related, nor equal variance with each group. A minimum 50 sample per one independent variable. So in short, logistic regression measures the relationship between the categorical dependent variable and one or more independent variables by estimating probabilities using a logistic function, which is the cumulative distribution function of a logistic distribution. Then another test of relationship is factor analysis. This is not designed to test hypotheses, but this technique is used extensively by researchers to develop and evaluate tests for scales. This may reduce and refine large number of question items into smaller and more manageable items. In short, factor analysis is a statistical method used to describe variability among observed correlated variables in terms of a potentially lower number of an observed variable called factors. For example, what is the factor that makes people religious? Then we have discriminant analysis. This method explores predictive ability of a set of independent variables on one categorical dependent variable. Discriminant analysis is used to differentiate groups based on several predictors or independent variables. This can have more than two groups on dependent variable. Example, if you want to differentiate a student failure or passed or standout based on the midterm and paper score. Then another test of relationship is the canonical correlation. This test is used when we want to analyze two sets of variables, usually used for exploratory research. Example, a set of variables measuring medical compliance, such as willingness to buy drugs or to make return office visits, to use drugs, or to restrict ability or to restrict activity, and a set of demographic characteristics such as educational level, religious affiliation, or income, or medical insurance. Another, we have structural equation modeling. This is known as a very sophisticated technique where we combine multiple regression with factor analysis or to evaluate model fit with your data. So this structural equation modeling includes a diverse set of mathematical models, computer algorithm, and statistical methods that fit networks of constructs of data. Then we have now the test of difference. First is the t-test. This is a test to comparing mean score difference between two groups. This consists of the independent, the paired, and one sample with different situation. T-test is most commonly applied when the test statistics would follow a normal distribution if the value of a scaling term is the test statistics were known. If the value of a scaling term and the test statistic were known. Then another is the Mann-Whitney U-test and Wilkinson-Saint-Rank test. This is also a measure of test of difference. However, it uses the non-parametric version of the t-test. When we say non-parametric, this is one that do not rely on any distribution. Then another test of difference is the one-way analysis of variance or the one-way ANOVA. This is a test to comparing mean score difference between two or more groups. In the analysis of variance, independent variable is grouped and the dependent variable is scored. And this can be used for same group or different group. While the Kroskal-Wallis test and the Friedman test is the non-parametric version of the one-way ANOVA. The next is the two-way analysis of variance or the two-way ANOVA. This is a test to comparing mean score difference from two independent variables or group. The independent variables are categorical, such as comparing the general point average between student enrollment group and gender. And this can be used for same group or different group. Now we have the multivariate analysis of variance or the Manova. This is test to comparing mean score difference with several dependent variables. It can be done one way or two-way. So Manova is a procedure for comparing multivariate sample means. It is used when there are two or more dependent variables and is often followed by significant tests, including individual dependent variables separately, involving individual dependent variables separately. Example, comparing leadership skills and general point average based on religion and gender of student. And finally, for the test of differences, we have the analysis of covariance or the ANCOVA. This is a test to comparing mean score difference with controlled covariate variable to minimize errors. Similar with partial correlation, and can be one-way, two-way, or multivariate. In short, ANCOVA is a blend of analysis of variance and regression. Example, if you are comparing leadership skills based on gender with controlled general point average. So for some tips on choosing the statistical tools, you have to remember that the research questions that you want to address, to find the questionnaire items and scales that you will use to address these questions, identify the nature of each of your variables, draw a diagram for each of your research question, that is if possible, and decide whether a parametric or a non-parametric statistical technique is appropriate. Okay, that would be all for this session, class. Check also for your references if you want to have additional information regarding the topic, and visit also your work text for some of the samples presented there. And if you still have questions, you can post that in the Google Classroom or in the group chat. Again, thank you for watching. See you in the next video.